Welcome to Programming Fluency. This is section 3.4, Loop Control and Nesting. So far, every loop you wrote ran all the way to the end. In this video, you learn how to stop a loop early, how to skip a single pass, and how to put one loop inside another. Let's begin. Let's meet the three tools that give you real control over a loop. They are break, continue, and nested loops. This is the plan for this video. First, you learn the break statement. It lets you leave a loop early, the moment you have found what you were looking for. Next, you meet the continue statement. It skips the rest of the current iteration and jumps straight to the next one. Then we look at nested loops, a loop placed inside another loop. You will use them to build tables and to print patterns. Finally, we handle escaping nested loops. You will see that break only exits the inner loop, and learn a clean way to exit both at once. A basic loop runs until its condition becomes false, but sometimes you need finer control. Let's look at three common cases. First, searching. You are looking through data and you want to stop the moment you find a match. There is no point checking the rest. Second, skipping. Some items are invalid. You want to skip them but keep processing everything else. Third, a loop inside a loop. You work through rows and columns, or you build every pair from a set of values. C gives you three tools for these cases. The first is break. The second is continue. And the third is nested loops. Let's meet them one at a time. The first tool is the break statement. You already saw break inside a switch where it exits the block. In a loop, break does the same kind of thing. It stops the loop right away. The definition is short. The break statement immediately exits the innermost for while or do while loop. The loop's condition is not checked again. Execution continues at the first line after the loop. Think of it as an emergency exit door in the middle of the loop. Let's find the smallest divisor of 84. This loop starts at 2 and counts up. Inside, we check one thing. Does I divide n evenly? We test that with n modulo I equals 0. The moment it does, we save the divisor and break. The break statement stops the loop right here. The output is, smallest divisor of 84 is 2. And this is the payoff. Without break, the loop would test every value from 2 to 83, even after finding 2. With break, it stops at the first match. For large numbers, that saves a lot of wasted work. Let's look at the control flow. There are two different ways execution can leave this loop. The first is the normal exit. The loop condition, I less than n, finally becomes false and the loop ends. The second is the early exit. When the inside condition is true, break fires. Follow the break arrow in the figure. It jumps straight to the code after the loop and skips the condition check completely. That is the key idea. Break does not wait for the condition. It leaves right now. This is a common pattern that pairs an infinite loop with break. The header while one is always true. So on its own, this loop never ends. The exit lives inside the body. Each pass, we check one thing. Is n times n greater than 100 if it is break? Otherwise, we print n times n, and then increase n by 1. So it prints 1 squared, 2 squared, and so on. It breaks when n reaches 11, because 11 times 11 is 121, which is more than 100. This pattern helps when the exit condition is easier to test after doing some work in the body. The second tool is continue. It is easy to mix up with break, so hold on to this contrast. Break exits the whole loop. Continue only skips the rest of this pass and then moves to the next one. The loop keeps running. The definition is short. Continue skips the remaining body of the current iteration and goes on to the next iteration. One detail to remember. In a for loop, the update, like I++, still runs. In a while loop, continue jumps straight to the condition check. Let's see continue in action. We want to add up the numbers from 1 to 20, but skip every multiple of 3. Inside the loop, we test I modulo 3 equals 0. When that is true, continue fires and we skip the rest of the body. That means we skip this line. Sum plus equals I, so this value is not added to the sum. The output is 147. So when I is 3, 6, 9, 12, 15, or 18, continue runs and we do not add that value. But notice one important thing. The update I++ still happens. In a for loop, continue does not skip the update. It only skips the rest of the body. This figure puts the two side by side, so you can see the difference clearly. Follow the continue arrow. It goes to the update step, I++, and then back to the condition. The loop keeps running. Now follow the break arrow, shown as a dashed path. It goes straight past the loop, all the way to the code after it. The loop stops. So continue means skip ahead to the next pass. Break means leave the loop entirely. Same kind of statement, but very different destinations. Here is a practical reason to reach for continue. It keeps your code shallow. On the left, the main work is wrapped inside an if block, so everything is indented and extra level. When that block is long, all that indentation adds up and gets hard to read. On the right, we flip it. If the item is not valid, continue skips to the next pass. Then the main work sits at the normal indentation level, not buried inside an if. For now, red is valid as a simple check. You will write your own functions like it in Chapter 4. The third tool is the nested loop. This is simply a loop inside another loop. The key behavior is this. The inner loop runs all the way through for each single pass of the outer loop. The counting rule is simple. If the outer loop runs m times and the inner loop runs n times, then the innermost body runs m times n in total. That multiplication matters, and we will come back to it. Here is the simplest nested loop, a multiplication table. The outer loop controls the rows. For each row, the inner loop prints all 4 columns. It prints row times col. The format, %4d, prints each number in a field 4 characters wide, which lines the columns up neatly. After the inner loop finishes a full row, print new line moves us to the next line. Then the outer loop advances, and the inner loop starts over from column 1. The outer loop runs 4 times, the inner loop runs 4 times, so the body runs 16 times in total. And this is the table it prints. Nested loops are the standard tool for printing shapes. Here is a right triangle of stars. The outer loop counts the rows. Look closely at the inner loop's upper bound. It is col less than or equal to row, so the number of stars depends on the current row. On row 1, the inner loop prints 1 star. On row 2, 2 stars. On row 3, 3 stars, and so on. That connection, where the inner loop's bound depends on the outer loop's variable, is the heart of nested loop patterns. Change that formula, and you change the shape. Here is a rule you must remember. When break appears inside nested loops, it exits only the innermost loop, not the outer one. In this code, the inner loop breaks when j reaches 3. So each row prints 1 and 2, then stops. But look at the output. The outer loop still runs all 3 times. Break ended the inner loop, but the outer loop kept going, starting the inner loop fresh each time from j equals 1. C has no break too. Break always leaves just the nearest enclosing loop. So how do you exit both loops at once? The standard way is a flag variable. Here we call it found and we start it at 0. We add it to both loop conditions with the and operator. The condition reads, keep going while I is less than 10 and found is still false. When we set found to 1, both conditions fail on the next check and both loops end. There is one other tool. C has a go-to statement that can jump straight past all enclosing loops. This is the one place go-to is sometimes accepted, exiting deeply nested loops, but use it rarely. For nearly everything, the structured tools keep your code clear and easy to follow. Here is a bug that catches many beginners. In a while loop, continue jumps straight to the condition check. In this code, the update I++ sits at the bottom of the body. So when I reaches 5, continue fires and skips right over this line. The value of I stays at 5 forever. 5 is still less than 10, so continue triggers again and the loop spins forever. The program prints 0 through 4, then hangs. The fix is to move the update before the continue, so it always runs. Or just use a for loop, whose update happens automatically every pass. Let's recap. Loops do not have to run all the way to the end. You now have 3 tools for control. Break exits the innermost loop right away. That is perfect for stopping a search once you find a match. Continue skips the rest of the current pass and moves to the next one. That is great for filtering out items. Nested loops run the inner loop fully for each pass of the outer loop, giving you m times n passes in total for tables and patterns. Remember, break exits only one loop. To exit both, use a flag variable or in rare cases goto. And in a while loop, always make sure the update runs before any continue, or your program will hang. Next, your programs can decide, repeat, and exit early, but they still run on data you typed into the code. In the next section, you will read real input from the user with scanf and validate it with loops.